In this presentation, we're gonna look at linked list sorting. So when we sort a linked list, normally we don't move the data, like in the case of array, but we just exchange the links. Suppose we have a linked list like this. So currently it is 1739. That is the order of elements in the list. After sorting, it will become 1 is here, link of 1 points to 3, link of 3 points to 7, and link of 7 points to 9. So it is 1379, which is sorted. As you can see, we have not changed the data in the nodes, but we have just exchanged the links. Now we're going to see a demo of this. So this is a function which does the sorting of a linked list. We have 5 temporary variables here, temp1 to temp5. So let me explain the use of each variable first. Temp1 and temp2 we are going to use for current node and next node. So temp1 will be pointing to current node and temp2 will be pointing to next node. Temp3 will be pointing to previous node. Temp5 is just a temporary variable used for swapping the nodes, and temp4 we are using for finding the end of the list. So once again, temp1 and temp2 current node and next node, temp3 previous node, temp5 is just a temporary variable used for swapping the links. Temp4 is a variable used to find the end of the list. Initially temp4 is null because we're going to traverse till the end of the list. What we are checking here is temp4 has not become the beginning of the list, which is the next node after the head node. So initially we are making temp3 is equal to temp1 equal to mylist head. So temp2 is the next node, so temp2 equal to temp1 dot link. So we have 2 while loops because it's a sorting algorithm. It's a bubble sort, so complexity is n squared. So we have 2 nested while loops. So this is the inner while loop. The condition we are checking is temp1 not equal to temp4. So in the first iteration this is going to be null because we are assigning it null here. Then what we are doing is we are comparing the data between temp1 and temp2. Temp1 is the current node and temp2 is the next node. If temp1 is greater, we are going to exchange it here. So this is pretty much a swapping logic if this condition is met. Else what we are doing is straightforward. We are going to the next node. We are storing temp1, the current value of the temp1, to temp3 as the previous node before we go to the next node. So this previous value is required for fixing up the links later, which we're going to see shortly. Now let's have a closer look into the swapping part. So if this condition is met, we are going to swap either here or here. So if you carefully look at the code, the only difference between this block and this block is this particular line. In the initial case, if you want to change the head node in which temp1 equal to head mylist head, you have to use this particular line because you are changing the list head. If you're not changing the list head, all you have to do is to change the link of the previous node. temp3 is the previous node. So that is the difference between these two blocks. So now let's have a walkthrough. So suppose this condition is met, what we need to do is temp2.link, that is the link of the next node, we are saving into a temporary variable. Then temp2.link is temp1, so we are going to exchange temp2 and temp1, and temp1.link is temp5. So this is pretty much straightforward swapping operation if you carefully look. Only thing is that we are swapping the links instead of the data. So temp5 we are saving the temp2.link, then temp2.link we are assigning it to temp1. Now temp2.link is pointing to temp1, and now temp1.link we are pointing to temp5. So the swapping is complete. Now we have another problem. The previous node is pointing to temp1, so that we have to change. So that's what we are doing here. MyListShed, or the previous link, in this case it is temp3.link, the previous node's link. Currently it is pointing to temp1, we are making it temp2 because we have swapped temp1 and temp2. Here we are saving the previous node, so now temp2 is the previous node, so we are assigning it to temp3. Same thing we are doing it here. So the use of the temp3 is this. The reason why we are using temp3 is we want to fix the link of the previous node after the swapping. So this we have already seen. So if there is no need of swapping, which means that this condition is not met, we will come here. There is no swapping. All we are doing is temp3 equal to temp1 because previous node is temp1. In this case we have done the swapping, that's why temp3 equal to temp2 instead of temp1. This is a straightforward traversing statement. temp1 equal to temp1.link, and after that we are making temp2 equal to temp1.link because temp2 is the next node. And now the last if statement is if temp2 equal to temp4, temp4 equal to temp1. More or less an optimization. So as I mentioned, temp4 is the limit of the inner iteration, because if temp1 equal to temp4, we are exiting from the inner while loop. So after the first iteration, we are assuming that the largest element will be in the end of the list. So it's a bubble sort. If you are new to bubble sort algorithm, feel free to review it. So it's a very simple sorting algorithm. In the case of this algorithm, after the first inner loop execution, we are assuming that the largest element is going to be the end of the list or the array, if it is in the case of array. So we don't have to traverse till the end of the list after the first iteration. So we can spare the last element after the first iteration. So that's what we are trying to do here. So if you remove this, it should work. It'll have more unnecessary iterations. So what we are doing is temp4 we are making it to temp1. In the case of first iteration, temp1 is the last node, and in the next iteration, temp4 is going to be second last node, and next iteration temp4 is going to be the third node from the end of the list. Like that we continue until temp4 becomes the next node from the beginning. In the sample we have this many elements, so we're gonna go through one or two iterations. So I really recommend that you go through all the iterations and try to understand each and every part of this program. If you want, you can adjust this value so that you can understand what is going on if required. So I'm going to have a clean run of this program without any breakpoints. So I'm removing this breakpoint. So this is the output of the program. So initially we have 1090, 130, 120, 130 and 5. So it's the exact same order we are adding it here. And after sorting, so we are calling sort operation here. After sorting, we have 5, 10, 90, 120, 130, 130. So now what I'm going to do is I'm going to put a breakpoint right here and restart the debugger. So currently temp4 is equal to null, which is this, and it is not equal to myListHead.link. Now temp3 and temp1 we are initializing it to myListHead, and temp2 equal to temp1.link, because temp2 is the next node. So we have not gone into this particular loop because temp1.data is 10 and temp2.data is 90. So this condition is not met. So we're gonna come here in the first case, or in the first iteration of the inner loop. So nothing interesting. We are saving the temp1 to temp3. Temp3 is the previous node, and moving to the next iteration. We are going to save temp1.link to temp2. So this condition is also not met. Temp2 is not equal to null. So we are not going inside that right now. This will get executed only in the end of the inner while loop. So we are going further. Again, temp1.data is 90 and temp2.data is 130, so no need of any swapping. Now in this case, temp1.data equal to 130 and temp2.data equal to 120. So in this case we need a swap. We are not at the beginning of the list, so temp1 is not equal to myListHead, so we are not going here. We're coming here, we are saving temp2, so we're gonna exchange temp2 and temp1. temp2.link we're gonna save it to temp5. temp2.link we're gonna assign it to temp1, and temp1.link equal to temp5. So currently temp3.link. If you look at that, you can see that it is 0x00615BE0, which is temp1 0x00615BE0. So that is what temp3 is pointing to. So temp3 is currently pointing to temp1, which is not what we want because we have exchanged temp1 and temp2. So what we need temp3 to point to. What we need is previous nod's link to be pointed to temp2. That's what we are doing here. And now temp2 is going to be the previous node. So that's what we are doing here. Temp3 equal to temp2. So I'm going to put another breakpoint here and pushing an F5. I'm not going through all the iterations. I'm leaving that as an exercise to you. One of the things I really recommend is observe this part. So put a breakpoint right here to find out what is the condition and see how it exactly works. So now let's go back to the slides. So we have seen this demo. So I wouldn't say that the program we have seen is simple and straightforward to everyone. Although once you understood, it's fairly straightforward. So it is a general practice. We run into this kind of complicated nested for loop, if loop, and conditions, nested conditions or logic. Here are a couple of tips I can give you to get into complicated programs in general, not just this one. So try to understand what exactly the algorithm does. So in this case we have seen that initial diagram of what we are trying to achieve. So try to understand the logic of the program before we look into the code. Once you understood the logic, try to implement that logic by yourself rather than looking into the code which is already working, written by someone else. So try to implement the logic which you understood by yourself. Now debug your code. Make sure that if the code is not working according to the logic, try to debug and change the code and try to make it work. So that should be the third step. If still it is not working, if it is working by that time, you would have understood the program. Assuming that it's not working after all your sincere efforts. Look at a working implementation and try to understand what you are missing. Also, try to debug and modify the working implementation. So from the working implementation, try to modify your sample such that you can make it work. If you can make your code work, there is nothing better you can do. If you don't understand any line of code in the working implementation by someone else, you can comment out that particular line and see what is the problem when you comment out that particular line. Following a couple of things we should never do when we try to understand some complicated code. Get into the working implementation without having a proper understanding of the logic. That is the last thing you should do. The code itself is complicated, and if you don't know what is the algorithm used in that code, it will be very difficult. You'll be spending hours extra. Also, never try to jump into the working implementation directly, which is written by someone else, without a sincere attempt from your side to write the code by yourself. Another thing I always recommend is never try to look at the working implementation simply into the code. without proper debugging or stepping into the code. So always use a debugger. When I say a debugger, it can be logging, it can be anything which helps you to understand line by line the change of the variables, the value in the variables at any point in time. Otherwise, practically you have to compile the code in your brain and you have to execute that code like a CPU does. It's very difficult. We are not computers at the end of the day. We are just human beings. Yeah, some people I know, they have a lot of imagination and they can do it, but most of us are normal people. So this is something I remember whenever I deal with complicated code. So the best practice is, if you need more than 3 level of indentation, there is a problem and you should fix it. But unfortunately, we may have to deal with bad code. In most cases you will be dealing with bad code which has more than 3 to 4 level of indentation. For example, the program we have seen just before, the linked list sorting, it has more than 5 level of indentation. So it is important for you to understand that how to deal with this kind of complications. So that brings us to the summary of the presentation. We have seen linked list sorting, a fairly complicated program. So there are a lot of links exchanging, etc. Also we have seen a couple of tips to deal with complication or complicated logic in the code effectively. That's it. Thank you very much.